Hey everyone, what is up? Welcome back to the channel. In today's episode, we're going to go over how to build our own Chat GPT. But it's going to be all local, it's going to be all private, and using open source models for both text-to-speech, speech-to-text, and LLM. All the acronyms. So let's get started right away. Why would we want to build our own Chat GPT? Chat GPT is pretty awesome. I think at this point everyone's using it. But the big thing is that you're sending all of your data to OpenAI. So just like when you do all these Google searches, Google has all of your data to then give you ads from other providers. So OpenAI hasn't done that just yet, but it's very likely that they will use it, and it's very likely that they're already using your data to train other models. So why not keep your own data, and why not use it on your own phone? So there are some positives and negatives. Positive is you're not sending your data everywhere, everything's private. Negatives is that the models that OpenAI uses are massive. So to give a little bit of perspective, it's probably in the 1 trillion plus parameters. So that means, like, let's say how big the database of information they have access to. Let's say they have access to all of Wikipedia per se. And then our model kind of has access to a few pages of Wikipedia. Maybe that's a good analogy, maybe not. We'll see. Maybe I'll come up with a better one. But essentially, is like how much data and how much processing power it has to come up with a good answer based on what you're looking for. The other thing is that since this does work completely offline, it's not going to get real-time information. So when ChatGPT first came out, if you were to ask, like, okay, did the Sixers win yesterday? It's not going to know. It only has like information from the last couple of months, not yesterday or like in real time. Of course, that's updated now, but our app won't have that, at least yet. It's a feature that we can add as a tool call, but right now it's just fully local and doesn't need internet to run. So let's get into the actual product that we're building. So the one thing I do love about ChatGPT is that I kind of made Chat UI the entire app. Whereas, like, we've done apps in the past where chat is just a single page in a 20 to 30 page application. So think of Threads. Threads has a chat page, but then it has like the feed, it has likes, it has a lot of things. Same thing with TikTok, and even the same thing with, some of the finance apps that we built. So it's a very simple UI, and all I did was use native one for this, but we don't even want to spend time on that because that's not the real part here. The real part here is, if we click the settings, the ability to download and use open source models. And we can see 4 options that I put here, and I put who the research team that built them, so it's a little bit more clear. So IBM built this Granite model, Google built the Gemma models, so they have Gemini, which is closed source for Google, and then they have the open source version of Gemma. Microsoft has 5.4, and then Alibaba has Qwen 3. They also have a bunch of other models, but these are the models that we can run on this phone. And for reference, like I said, OpenAI has 1 trillion plus parameters, and we're looking at 2 billion, 4 billion, 4 billion. And that's because we are limited in resources. When OpenAI runs these servers, they have massive computers that are able to process information very quickly and giving you a quick response. We don't have that ability on an iPhone in this scenario. While I do think Apple and Android are going to be coming up with phones that have a lot more processing power moving forward, especially to have AI on device. I think that's Apple's I think that's what they're going to try and push forward for, since they're so far behind in AI. They're going to go for the local route. But in the meantime, we're just going to build our own version. So these are the models. We're going to go over some of those in a second. This is the prompt. So right now it's a very simple prompt. We can change this however we want. And then we have voice. So voice is actually the most exciting part for me, because there was clear solutions to speech to text, and then the LLMs. There's a lot of options, but there's only so many options that can run on a phone. And so we're actually using Koro, I don't know how you say it correctly, and it's an Onyx model. So we're going to go over that and how we implemented that as well. So let's just test what we're doing here. So if we click, we could either type in here, hello world, or we can use this little icon and we could record everything that we're saying. So you could ask the LLM any type of question that you want. And we're just going to click it and it sends right away. So we could say, and we could record everything that we're saying, blah, blah, blah. And then this is using Whisper, a speech to text model. And once it gets sent, it gets transcribed, it gets sent to the LLM, and then the LLM responds back. And so the timing is going to be a little bit different because this is an emulator. It's running on my computer. The iPhone app is actually a little faster sometimes, but then, yeah, actually I don't want to get too into it. And then understood, we'll be ready to answer. I'm going to click play.
Understood. I'll be ready to answer your queries. Let's proceed.
So it's not perfect because you can see the pauses it has in the sentence aren't always perfect. But there's room to improve it moving forward. But we have all of the main pieces to create a Chat GPT. So let's get into, and it's all private, so we could clear the history, and since everything's on the device, we could either keep a long running list so it has more context of us, or we could just start from scratch every single time. Okay, so now let's get into the LLMs and a little bit more information about the LLMs that we picked, why we picked them, and how we get them on the device. So the reason I picked them is that there's this Hugging Face, so you haven't heard of it. It's basically a repository of all these open source models. And there's new ones coming every single day. The industry is changing so quickly that by the time this video comes out, maybe this list is completely different. But for right now, we're using a couple models that have worked well for on-device specifically. So I'm going to click this only official providers because there are a lot of people. Of course, it's open source, so people can create their own models. They could take models and then tweak them to do however they want. So you could train them differently than they were originally trained for. But we're going to use only official providers, and we're going to click for edge devices. So that would be our phone. So they need to be small enough to run on the phone. And you can see when we click that, all the options go from 72 billion, 32 billion, 70 billion, 52 billion to 2 billion, to 1.5, 1.5, to 1.5, to, and that's because of the resources we have available. And we can see the top two in this category are IBM Granite, 3.2 and 3.1. So I just used the newer one, 3.2, 2 billion. And then I actually used an older one. So when this is coming out, Gemma 3 is out. I think they only have a 1 billion model, but I wanted to use a 2 billion model. And it's a little further down the list, unless I missed it. Here's the Japan. Here we go. Gemma 2 to be IT, and IT means instruct. So we're going to do instruct models because there's the difference between instruct and thinking. So instruct is like short, quick answers, kind of to the point. Really good for tool calling, which I'm going to get to in the future. Maybe I'm going to integrate our Home Assistant functionality into our application. But for right now, we're just going to do instruct and versus thinking. So thinking requires a little bit more resources, takes a little bit more time. And so I want to stick with instruct so that it's very straightforward. Maybe we could add a thinking model in the future. But to kind of keep it on the same level for all the models that we picked, we're just going to go with instruct. And just because there's a newer model doesn't mean it's necessarily better. A lot of times it is better, but doesn't necessarily. So Gemma 2 is one that has been proven to be pretty consistent with answers, hallucinate very little for the size. So the problem with some of these smaller models is that if you ask it to do some complex task, it's going to confidently give you an answer back. And that's what hallucination is. And it's a little hard for these smaller models to not hallucinate unless like you're restricting the resources that you give to it. So let's say you give it some huge prompt. If we go back here and we make some like 2-page long prompt and then try to ask it questions, it's probably not going to do well because it just doesn't have the resources to take in the huge prompt along with the question that you're asking and to be able to answer it in a quick and a concise way. So that's why our prompt is super small, but you can also edit and play around with it here. And so if we go back to here, a lot of the suggested models are very small models, 1.5 and 7. But some other good models that we did use a little bit higher for consumers is the 5.4 mini instruct, and then the Qwen model. So we have Qwen 2.5 here, but we're actually using the Qwen 3 4 billion model, which is a newer version. So of course, as you get bigger and bigger models, you're going to get better and better scores. You can see, I mean, just look at the green area versus, they get better and better. So if you have like a huge GPU, of course, that's going to be the best option. So that's where APIs come into play. But again, we're sticking with on-device. And two of the best models we could load onto the device are the 5.4 mini and the Qwen 3 4B. So these are just both 4 billion models. I actually tried with larger models. I tried with the Qwen 3 8B or 7B, I forget which one it was. And it actually loaded in the emulator, and it was a little deceiving because it did work in the emulator, but the emulator has the resources of the computer, which is a lot more than the phone. So once I published it to the phone app, it wouldn't even load the model. It didn't even have the resources to be able to load that model. So we can see, if we go back to, let's say this is the one we're using, 3.2 2 billion instruct. We can see if we go to IBM Granite, we have all these files, but what we actually want is a GGUF model. And we want a GGUF models because we're using a library called Llama CPP. So Llama CPP is just a way to create interference for these models. So it's basically just a way to load the models and to use the model. So Llama CPP is one option of a few, but it's also the most, I think, flexible. It's used by a lot of applications, not just iOS, Android, Mac, Linux, all over the place. There are interference engines that are better for Macs, better for iPhones. Like there's a format called MLX, which will only work on Apple Silicon, but this is a React Native app, so we want to use it on both applications. So given that and the fact that Llama CPP itself is C++, it can't directly run on React Native, but there is a React Native bridge to be able to leverage this code in React Native so that we could run it locally. And back to GGUF, it's kind of the model file type that once a new model comes out, you'll see like these safe tensors and tokenizers that can be run. But like right after that, and even sometimes by IBM itself, you can see they have this GGUF model. So even if they don't release their own GGUF models, there's a lot of people, Bartowski and drawing a blank on the other one, of companies or people that will quantize them and then release those same models to people. And so what quantization is it's kind of bundling up all these files for this model and reducing the size and reducing some of the parameters and like the ability to, I guess, create some of the connections. Like let's think of the model as a brain, and you're kind of maybe reducing some of the brain connections, but you're also reducing the size of it. Or if you have a full F16 model, you're using all the available resources. I think the meme of like the guy like just thinking of like the universe has the resources to everything available to it. So this is the largest model, and then we have like the smallest, most quantized version of Q2K GGUF. So hopefully that makes, maybe I need a better few analogies, but what essentially is, it makes the model dumber, but it also makes it smaller to be able to fit on a phone. These are the smartest ones, but also maybe the slowest, or maybe it won't even fit on the phone. So we're actually going to pick models right in the between, right in the sweet spot. So we don't want it to like go too far quantized, because that's when you get real bad hallucinations. But we also might not necessarily be able to run this efficiently on the phone. Let's say it loads into the app, but if you ask it a question, maybe it takes 45 seconds to return an answer instead of 4 seconds. That's a big difference. One is usable and one is not really that usable. So just because it says 1.55 versus 5 and you have a 100 gig iPhone, sure, it could load on there, but once it loads into the Llama CPP, the interference engine, it takes up a bunch of RAM. So you might have storage of 100 gigs, but the RAM on an iPhone might only be 8 gigs. And so if this isn't the RAM right here, this is just the actual file size, but it doesn't have like references to the actual RAM here. But let's say this Q4 KM model requires 4 gigs of RAM. This one might require 5, 6, maybe even more gigs of RAM. So if you have an 8 gigabyte iPhone with RAM, let's say 2 gigs of RAM are already used by the system, then you only have 6 gigs, and then you're even pushing it. So I don't want to get too much into the details because I'm making generalizations here, but essentially is we want to go with this quantized 4QKM. So the next thing we want is the ability to convert speech to text. So when I click this button, it passes in audio, and then it takes that audio and it transcribes it into text. So you can't just pass in audio into an LLM directly. At least most of them you can't. There are some models that you can do speech to speech, but there's very few, and I don't think I've seen any that actually work on a phone just yet. I know Google has one, but essentially the workflow goes, take this audio file of speech, turn that speech into text, pass that text into Llama CPP, which has a model loaded into it. That model thinks about its response and responds back to you in text, and then that text we're going to use for TTS, which is text to speech, with a Koro model. So let's do the first part of the speech to text. So the speech to text, we have another really good option for Whisper CPP. So Whisper is basically, CPP is an engine specifically for the audio side. It's still a model, but it's a model trained on audio to turn into text. So unlike a model that has, an LLM model that has, let's say, 1 trillion parameters, because there's almost an infinite amount of answers for the questions that you could ask. For audio, there's only so many words in the English dictionary, so that needs less parameters to be able to tell what you're saying. And one good thing that OpenAI did was they released Whisper. OpenAI. They released Whisper, so it's OpenAI because they meant to open source a lot of stuff. It took a while for them to actually do that, but this is a really reliable source for converting audio to text. And if we scroll down here, we can see, just like we have different versions and different sizes of LLM models, we have the same thing for this audio to text model. So this one's a little easier to read because there's not a million LLM models. There's not as many audio to text models as there are LLM models. It's more specific. So this is a widely used model. And we can see a couple different things. Now we're in the parameters of 39 million parameters. So we went from 1 trillion with OpenAI, we went to 2 to 4 billion with our LLMs, and now we're at 39 million for our speech to text. Yes, speech to text. I always get those mixed up. So we have this tiny, base, small, medium, large, turbo. Of course, this is what we're looking at, required VRAM. So okay, these two aren't bad, about 1 gig of VRAM. And like I said, if the phone is 8 gigs, 2 to 3 for system, then these can run just fine. Then small might be pushing it because we have to account for all the other models that we have. We can't have a LLM model using up all of our resources and then just not have enough for the speech to text or the text to speech. So this one's pushing it. We probably could run it, but we actually picked this base model because it was pretty accurate. It only has 74 million parameters, only takes up about a gig of space, and it's fast. That's the big thing, fast. Medium, it probably, if this is the only thing you're running, you might be able to load it onto a phone, but it's just not worth it. And then we have this large and turbo, which there's no way that it's going to be running on the phone at all. And so we're going to go with this base model for our speech to text. And then the last thing we have is the text to speech. So this one was actually the hardest because there's the least amount of providers that could run on a device. So if we go to Hugging Face, go to models, we have the ability to select a bunch of different things here. So we have text to speech, text generation. Text generation is the basic one that we're used to. But what we want is text to speech. And if we click that, we do have a lot of models, and there's a lot of new ones coming out. Newest Air is one I tried to get running, but the one we're actually going with is Koro 82 million. So you can see that these speech and text models require a lot less parameters. Even this one is 0.7 billion, so 700 million. 700 million parameters, yes. Jeez. And then this one's really tiny. This one's only 82 million. So the crazy part is like how good it sounds for these small amount of parameters. And the reason why we're using this one is not because it's the best one available, because it did come out, let's say 8 months ago, but it's because it can run in an ONNX model. So it has an ONNX model, so ONNX. Let's see, we come here, and we have like similar quantization versions. So we have the FP16 again, we have Q4 F16, model quantized, so you can see all the different sizes. And of course, the smaller the size, the lower the quality. And why are we picking an ONNX model? So the reason is because each one of these models, whether from its text to speech, speech to text, and then a just LLM model, like a typical OpenAI, they all require different interference engines to be able to run. And so there is a standard around the LLMs, which is Llama CPP, and there's other options like MLX, and I won't get into that right now. But with speech to text and text to speech, they need their own different separate engines. And then we have the Whisper CPP, which has been around for a while. Let's see. The first commit. I don't even know how you see the very first. Take my word for it. I don't want to go through. It's been around for a while, and so there's a lot of tools around it. Koro has been around for 8 months, which I guess in AI world is an eternity. So at least we have the ONNX models, ONNX models. But the other one, Newest Air, which I wanted to use, has only been out for one month. So there's only so many models that can run on the device. And then this one needs its own decoder. So not only does it need a ONNX model to run, but then it needs a separate decoder to be able to transform that. And so that was a fun part of trying to get Koro working, because that's also why there's a little bit of pause sometimes when it speaks out. So finally, all of this, let's get into the code real quick and go over how everything is set up. And so if we come here, let's move my face so I'm not in the middle of everything. Like I said, we're using React Native so that we could run on both devices. First setup, layout, we have only a single page, so our chat screen. And we have this set up. This is Expo router. We're using routes. This just routes to this SRC folder, the source folder. In here, we'll expand everything. We have components. We got hooks. We got lib. And basically, this main chat screen is everything that's going on, and everything is kind of attached onto there. And so when we first reload the screen, let's actually pull this in so we can see both at the same time. Let's reload. And we can see on load, one thing I did was actually store locally. So if you want to keep your chat history, you could, or you could remove it. So let's remove it. And then on initial load, it will load the files in. So one requirement by Apple was to like prompt the user to make sure they know they're downloading different files. So you have to download the Whisper model, and download the IBM Granite model at first. The other three just are there and you can change it, you don't have to download them. And then the Koro model, the biggest one of course is the Granite one. If we click this 2 billion one, we can see what this looks like. So download require for AI chat responses, download now. You can see it's 1.4 gigs. Let's just say not now. We won't be able to use it if it's not now. So what we do on load is, if we don't already have those downloaded, we're gonna ask the user to download them from Hugging Face so that they're available locally. So you do need internet on the first load, and then what's from there, you don't need it anymore. Once the models are loaded, they all load them into these applications. So like I said, we'll have the Granite model loaded into Llama CPP or Llama RN in this case, which is just a bridge to be able to use that in React Native. The same thing for Whisper CPP. There's a bridge called Whisper RN that the Whisper model gets loaded in. So there's like a 2-second, 3-second delay of those models just loading into RAM. So they're loading into memory so that we can actually use them. And then finally the Koro model, which is loaded with the ONX runtime. Let's see. So we have Llama RN, Whisper RN, and then Onyx React Native runtime, which is for the Koro model. So the first thing we'll go to is the screen. So we have all these functions to be able to handle download models. And then we have handle TTS. So if we do, actually let's find the one for, so we have load initialize LLM model. So these use effects will wait until the model's downloaded, and then they'll load into the interference engines. Load Whisper, handle voice. Okay, this handle voice is the one I was looking for. So this handle voice gets called when we click this little button, and then we start talking into it. So it'll take in all the audio with Expo audio, save it as a WAV file, push it into the Whisper model, and then I gotta clean up this on the light mode. I don't like the blue. And then put that audio into Whisper CPP or Whisper RN, transcribe it, send it to the LLM with Llama RN, and then finally return that text to Koro to play out.
Understood. I'll record your audio using Expo Audio when you press this button.
Pretty good. And then it'll just like be a touchscreen. So a few of the things that we have the config, so we could see the LLM config, and we could change the length of response that's allowed. Let's say, hey, can you write me a long bedtime story for my child? So sometimes if you ask this question, the token response might be too short. So you can see that if we want it to perform faster, we have to reduce the amount of tokens, but if we want a longer response, it's going to be a little slower. And so it's kind of that black boxy thing of trying to find that good middle ground, just like we did the good middle ground of quantization, finding a good level of like size to fit on the device, but also quality on the output. You do the same thing for the LLM config. You do that all with Llama CPP. And then let's play this. Actually, I don't want to play this because this is going to be really long, but you get the point. We're just loading in with all the index, model manager. This is basically, once you click one of these, it'll download the files from Hugging Face and store them locally. So these are all the the GGUF model, so you can see .gguf, and this is the other one, Unsloth. So Microsoft created the original model, Unsloth created the GGUF version. Storage is all locally, so instead of every single time you reload it, removing everything, I just added local storage so that the user can decide what they want. It also stores the audio files locally if they want to replay it back, but then once you click delete, it just removes everything completely. Types, self-explanatory. Update manager is just Expo updates. Voice manager. We have a good amount of voices, and we changed the speed of it as well. And so let's try George super fast. Hey George, how you doing today? Oh man, this is a slow response. He's thinking how good he's doing today. But in the meantime, we have the components, which is just the UI for the modal itself, chat and index, loading them in, and then we have hooks just to be able to have the conversation go back and forth, store that locally, and then preferences, and then theme to be able to black-white theme. So let's play this last one. Let's make sure my audio
function will. Thanks for asking. How can I assist you today?
super fast. So there's a lot of functionality here, but a lot of room for things that we could add. Like I said, in the future, this will probably be the base of adding more and more features that we want to add on to it. But I'm going to open source this. It's also going to be in the App Store if you just want to download it itself, but the code will be on GitHub as well. So hope you enjoyed this course, learned a lot. Hopefully it wasn't too confusing with all the different models and interference engines. I'll keep on touching on this because it is interesting. It's also a lot to take in, but once you get into it, once you start to use them yourself, it does become a lot more self-explanatory. So hope you join me next time. See ya. Peace.